Hey there, fellow philosophers. Today's deep dive is going to be right up your alley.
Oh, yeah.
We're diving into the world of neuroscience,
Right.
but through a philosopher's lens, all those big questions we've been wrestling with forever, like consciousness,
Mhm.
free will,
Yeah.
the meaning of life.
The big ones.
Well, we've got a whole stack of articles and research here that suggests neuroscience might actually have some answers.
At least some serious food for thought.
Yeah, for sure, or at least some seriously thought-provoking challenges.
What I find so fascinating is how, for so long, philosophy and neuroscience were totally separate worlds.
Right, they were in their own little silos.
Philosophers were off contemplating the mind, where neuroscientists were mapping out the physical brain.
Yeah, it's like they were speaking different languages.
Totally, but now things are changing.
I mean, think about those early philosophers. They could ponder the soul,
Yeah.
the self, the meaning of existence,
Right.
without ever looking at an actual brain scan.
Exactly. And to be fair, neuroscience back then wasn't exactly giving them much to work with.
Right, it's all pretty rudimentary.
But things have changed dramatically. Neuroscience has come a long way.
Yeah, it's like it's suddenly become this powerhouse.
And it's starting to encroach on philosophy's territory in a big way.
Yeah, it's forcing us to confront some really uncomfortable questions.
Like, what does it even mean to have a mind if we can explain everything with neurons and synapses?
Okay, so we've gone from philosophical indifference to what some are calling neurophilosophy.
Ah, yes, neurophilosophy, the bridge between mind and brain.
Right, it's where things get really interesting.
It's using the tools of neuroscience to try and solve those age-old philosophical puzzles.
And one of the most radical ideas to come out of this is eliminative materialism.
Oh, yeah, that's a mind bender.
Right, it really throws a wrench into the works.
It basically says that the way we talk about the mind, like with beliefs, desire, intention.
Right, our everyday language,
Yeah, all of that, it's just wrong.
like totally off base.
It's like some outdated folk theory that needs to be completely replaced with a neuroscientific explanation.
So you're saying all those philosophical debates about the nature of beliefs,
Uh-huh.
the problem of free will,
Yep.
all of that was based on a faulty understanding of what's actually happening in our brains.
That's the claim, and they have some pretty compelling evidence from neuroscience to back it up.
Okay, I'm intrigued.
One of their main arguments comes from how neural networks work, specifically this idea of vector spaces.
Okay, I remember hearing about those, something about how the brain represents information in these multidimensional spaces.
Yeah, exactly.
It always sounded a bit abstract to me, though.
It is abstract, but it's incredibly powerful. Think of it like a space where each point represents a different combination of features.
Okay, so like a giant map of the mind.
Exactly. So let's say you're thinking about a cat.
Okay, furry little feline.
Your brain might activate a point in this space that represents all the cat-like features, furry, four-legged mouse, chases mice. That point, that vector, that's your brain's representation of cat.
So instead of thinking in terms of sentences like, there is a cat on the mat, my brain is doing some kind of complex spatial calculation.
Precisely. And that's where the challenge to traditional philosophy comes in.
Okay, I see where you're going with this.
Because these vector representations are so different from how philosophers have traditionally thought about beliefs.
Right, with propositions and logic.
Exactly. It raises the question of whether our everyday understanding of the mind is even compatible with how the brain actually works.
So you're saying that the way my brain represents cat is fundamentally different from how philosophers have traditionally thought about beliefs.
That's the idea.
Wow, that's a huge challenge to our understanding of what a belief even is.
It is, and that's just the beginning. Neuroscience is starting to give us insights into all sorts of mental phenomena, from perception to emotion.
It's like we're seeing the mind in a whole new light.
Exactly, and in many cases those insights are forcing us to rethink some of our most basic philosophical assumptions.
Okay, so my mind is officially blown. I think I need to go back and reread all those philosophy classics with a fresh perspective.
You and me both.
But before we go down that rabbit hole, let's talk about another area where neuroscience is shaking things up.
Okay, I'm listening.
Psychosemantics, the study of how mental states get their meaning.
Ah, yes, the question of meaning, another philosophical puzzle.
Right, how do our thoughts and feelings actually refer to things in the world? How do they hook onto reality?
It's like cracking open the dictionary of the mind.
Yeah, but instead of definitions, we're finding neurons and synapses.
Exactly, and what's exciting is that neuroscience is giving us new tools to explore this territory.
So we're not just stuck in the armchair anymore.
We're getting down to the nitty-gritty details of how meaning is actually constructed in the brain.
All right, let's get into those details then, because this is a deep dive and we need to get to the bottom of this.
Let's dive in.
So how are neuroscientists tackling this question of meaning? How our thoughts actually connect to the world?
Well, it's definitely not as simple as having like a little dictionary in our brains.
Right, no neural dictionary with definitions for every concept.
Exactly. It's much more intricate than that. There are two main approaches that are being explored right now. One is called functional role semantics, and it focuses on the relationships between different representations in the brain.
Okay, so like a network of interconnected concepts.
Yes, exactly, like a giant web of meaning.
So the meaning of cat isn't just some isolated neuron firing. It's about how that firing pattern connects to other patterns. You know, the ones for like furry, meows, chases mice.
Right, all those features that make up our understanding of cat.
And I guess the more connections there are, the richer my concept of cat becomes.
Exactly. And remember those vector spaces we talked about earlier?
Yeah, those multidimensional spaces.
Well, Paul Churchland, one of the pioneers of neurophilosophy, developed a theory called state-space semantics, where he used the idea of vector spaces to explain how these conceptual relationships might actually work in the brain.
Okay, so how does this state-space semantics thing work?
So imagine a multidimensional space, kind of like a map, where each dimension represents a different feature or concept.
Right, I'm picturing it.
And each point in that space represents a particular combination of those features. That's how Churchland envisioned the brain representing things from simple sensations like colors and tastes to really complex concepts like justice or freedom.
So my brain isn't storing a list of definitions, it's creating this elaborate map of concepts with each concept defined by its relationship to all the others.
That's the idea. It's a very different way of thinking about meaning.
Yeah, it's pretty mind-blowing when you think about it.
It definitely challenges the traditional philosophical view of concepts as these discrete, well-defined entities.
Right, it's not like each concept has its own little box in my brain.
No, it's all about connections and relationships.
But what about that other approach you mentioned, the informational one?
Right, informational semantic, that one takes a different approach. It focuses on the causal relationship between a mental state and the thing it represents.
So it's about how our thoughts are grounded in the real world.
Exactly. A classic example is the idea of feature detectors in the brain. You know those neurons that fire when a frog sees a fly?
Ah, yes, the classic frog and fly experiment.
So the idea is that if there's a neuron in my brain that fires every time I see a coffee cup, then that neuron is somehow representing the concept of coffee cup.
Okay, so it's like a direct link between the neuron and the object in the world.
But like with most things in philosophy of mind, it's not quite that simple.
There's always a catch.
Right. Kathleen Akins, a philosopher who specializes in sensory systems, has pointed out that just because a neuron responds to something doesn't mean it's actually representing it in a way that's meaningful for the organism.
Okay, so there's more to it than just a neuron firing.
Exactly. She uses the example of thermoreceptors, those cells in our skin that detect temperature.
Oh yeah, the ones that tell us if something is hot or cold.
Right, they're very sensitive to changes in temperature, but Akins argues that they don't actually represent temperature in the same way that we as conscious humans experience it.
So my thermoreceptors are just registering raw data about heat and cold.
Right, they're not thinking, ooh, that's a nice warm cup of tea, or ouch, that stove is burning hot.
Interesting. So they're like these little localized sensors just responding to their immediate environment?
Exactly, without any of the higher level processing that goes into our subjective experience of temperature.
This is making me wonder how much we actually take for granted about the relationship between neural activity and conscious experience.
Yeah, it's a really complex issue.
But speaking of things we take for granted, what about consciousness itself? Surely neuroscience has something to say about that grand mystery, right?
Absolutely, consciousness is one of the hottest topics in neurophilosophy.
Yeah, it's the holy grail of mind-brain research.
And it's another area where traditional philosophical arguments are clashing with new scientific discoveries.
Okay, well, let's dive into that plash then, because this is a deep dive after all, and we need to get to the bottom of this.
All right, remember Thomas Nagel and his famous question, what is it like to be a bat?
Of course, it's the classic argument for the subjectivity of experience.
Exactly. No matter how much we learn about a bat's brain, we can never truly know what it feels like to be a bat, to experience the world through sonar.
To hang upside down in a cave.
Exactly.
But haven't some neurophilosophers pushed back against this idea?
They have. John Duro, for example, argued that Nagel's argument relies on some hidden assumptions about the relationship between physiology and phenomenology.
So he's saying there's more to the story.
Exactly. And Kathleen Akins, who we just talked about, has actually delved into bat neurobiology to suggest that many of the questions we have about bat experience are actually tied to how their brains work, questions that neuroscience might eventually be able to answer.
So instead of assuming that bat experience is forever beyond us,
Right.
maybe we need to keep digging deeper into those neural mechanisms.
Exactly.
But how do we even begin to study something as elusive as subjective experience?
Well, one approach has been to look for what are called the neural correlates of consciousness.
Neural correlates? Okay, so we're not talking about like a full explanation of consciousness just yet.
Right, not yet.
More like a roadmap of the brain areas that are involved.
Exactly. We're not at the point where we can say, here's how consciousness arises from neural activity.
Right, it's still a mystery.
But we are getting closer to understanding which parts of the brain and which kinds of neural processes are essential for generating conscious experience.
And how are philosophers reacting to these neuroscientific findings? Is there any kind of consensus on how to bridge that gap between brain activity and subjective experience?
Well, there's still a lot of debate. Some philosophers like David Chalmers argue that even if we map out all the neural correlates of consciousness, we'll still be left with what he calls an explanatory gap.
An explanatory gap, what does that mean?
Chalmers is basically saying that there's a fundamental difference between explaining the physical processes in the brain.
Okay, the nuts and bolts.
Right, and explaining why those processes actually give rise to subjective experience, what it feels like to be conscious.
So, like, we can imagine a creature that has all the same neural activity as us,
Mm-hmm.
but doesn't actually experience anything.
Exactly like a zombie.
Okay, I'm not sure I'm comfortable with that idea, but I see what you're saying is like there's something missing, something that neuroscience can't quite capture yet.
Exactly, but other philosophers like Paul and Patricia Churchland have pushed back against this idea of an explanatory gap.
Oh, really? So what's their take?
They argue that the more we learn about the brain,
Hmm.
the harder it becomes to imagine consciousness coming from anything other than these physical processes.
So it's a matter of bridging that explanatory gap of showing how those neural mechanisms actually produce subjective experience.
Precisely. And the Churchlands point to specific neuroscientific findings to back up their claims. For example, Paul Churchland has developed a pretty detailed account of consciousness based on something called thalamocortical recurrency.
Recurrency, that sounds familiar. Can you remind me what that is?
Think of it like an echo chamber in the brain where information bounces back and forth between the thalamus and the cortex.
Okay, right. I remember now. And Churchland is arguing that this kind of recurrent activity is key to generating those features we associate with consciousness, like selective attention, working memory, even dreaming.
Exactly. It's not just about which neurons are firing, it's about how those firing patterns reverberate throughout the brain, creating a dynamic and integrated experience.
So we're starting to move beyond those sort of vague philosophical explanations of consciousness
Right.
and getting down into the nitty-gritty details of neural mechanisms.
Exactly. And it's not just about consciousness either. Neuroscience is also helping us to understand all sorts of other cognitive functions like how we perceive the world, how we make decisions, how we learn and remember.
Right? It's giving us a whole new perspective on how the mind works.
And one of the classic methods for studying these functions is something called the lesion study, where researchers look at the effects of damage to particular brain areas.
Like those early studies of aphasia where damage to Broca's area impaired speech production.
Exactly. By seeing what breaks down, we can learn how the brain works when it's not broken.
Right. It's like reverse engineering the mind.
And Barbara von Eckart-Klein, another pioneering neurophilosopher, actually analyzed the logic of these lesion studies. She argued that they involve a two-step reasoning process. First, you identify the functional deficit based on the behavioral abnormalities.
So like if someone can't speak after a stroke.
Right, and then you infer the function of that area in normal brains based on the location of the damage.
So if the damage is in Broca's area, then Broca's area must be involved in speech possession.
Exactly. But von Eckart-Klein was also careful to point out that these inferences are only as good as the theories we're working with.
Right, we can't just jump to conclusions.
And she really emphasized the importance of integrating findings from different levels of analysis, from the psychological down to the neural, to develop more sophisticated and accurate models of cognitive function.
So it's about connecting the dots, seeing how those different pieces of the puzzle fit together.
Exactly. And that brings us to another huge development in neuroscience brain imaging techniques like PET and fMRI.
Yeah, those colorful brain scans.
Exactly. These tools have given us an unprecedented glimpse into the working brain.
It's like we can actually see the mind in action.
And they've been essential for mapping out the neural correlates of a wide range of cognitive functions, from language processing to decision-making.
It seems like there are also philosophical challenges in interpreting those images, though, right?
Absolutely. We need to be careful not to overinterpret the data.
It's not like we can just point to a glowing blob on an fMRI scan and say, aha, that's where consciousness happens.
Right. It's much more complicated than that.
But with that said, fMRI and other brain imaging techniques have given us incredible insights into how the brain works. And they've really sparked a whole new wave of research in philosophy of neuroscience. It's amazing to think how far we've come in understanding the brain.
It really is.
But it seems like there's always more to learn. What are some of the recent trends in philosophy of neuroscience that have emerged in the past decade or so?
Well, one major trend has been the rise of what's called the mechanistic approach to understanding the brain. It's all about understanding the brain as a complex system.
Mechanism. So we're talking about like gears and levers in the brain.
Not exactly, but the basic idea is that we can understand the brain as this system of interacting parts, each with its own specific function, kind of like a machine.
Okay, so like breaking down a complicated machine into its individual components to see how they work together.
Exactly, and this approach has been really influential in philosophy of neuroscience, especially when it comes to explaining how these complex cognitive functions come about, from simpler neural processes.
So instead of just saying that this brain area lights up during this task, we need to explain how that activity actually contributes to the task, what the underlying mechanisms are.
Precisely. And Carl Craver, one of the key people in this area, argues that good explanations in neuroscience should identify the specific mechanisms that produce a phenomenon.
So like a detailed wiring diagram of the brain.
In a way, and Craver also emphasizes that these mechanisms often operate at multiple levels, meaning they involve processes that are happening at different scales, from the molecular level all the way up to the systems level.
So it's like zoom in, zoom out to truly understand how the brain works.
Exactly. And this idea of multi-level mechanisms has led to some interesting debates about the relationship between psychology and neuroscience.
Oh, how so?
Well, some philosophers like Gualtiero Piccinini and Carl Craver have argued that psychology can actually be seen as providing like mechanism sketches
Okay.
that neuroscience can then fill in with the details about the underlying neural processes.
So psychology is like the blueprint, and neuroscience is the construction crew.
That's one way to think about it, but it's important to remember that this doesn't mean psychology is somehow less important or less scientific than neuroscience. They both bring their own unique perspectives and tools to the table.
Right? It's a collaborative effort.
Exactly. And another area where we see this kind of interdisciplinary approach is in the study of temporal representation.
Temporal representation, so how the brain represents time.
Exactly. And this has been a hot topic in both philosophy and neuroscience, with philosophers like Dan Lloyd and Rick Grush really highlighting the unique challenges of understanding how our brains represent something as fleeting and subjective as time.
Yeah, time flies when you're having fun, but how does the brain actually keep track of it all?
That's the big question, and one promising approach has been to use computational models like recurrent neural networks to try and simulate how the brain might represent time.
Recurrent networks, again, those seem to be everywhere in computational neuroscience.
They are, and their ability to process information over time makes them really well suited for studying this kind of temporal representation.
So the idea is that these recurrent networks might be able to capture that dynamic, ever-changing nature of our experience of time.
Exactly, and this kind of computational modeling has become increasingly important in philosophy of neuroscience as researchers try to bridge that gap between those abstract philosophical concepts and the actual neural mechanisms that might underlie them.
It's like we're trying to build a bridge between the mind and the brain, using the tools of both philosophy and neuroscience.
That's a great way to put it, and as we keep building that bridge, we're bound to encounter even more fascinating challenges and insights.
So what does this all mean for us as philosophers? We've gone from vector spaces to the meaning of meaning, we've tackled consciousness, and even the nature of time itself. It's enough to make your neurons fire.
Yeah, it's a lot to process, but I think what stands out to me is how much neuroscience is challenging us to rethink some of our most basic assumptions about the mind. It's not just adding new information, it's making us question the very categories and frameworks we've been using to understand ourselves for centuries.
Exactly, and that's what makes this such an exciting time to be working at the intersection of philosophy and neuroscience. It's a field full of unanswered questions, but with every new discovery, we're getting closer to understanding the most complex and mysterious thing in the universe, the human mind.
Couldn't agree more.
One final thought to ponder: if our understanding of the mind is so shaped by our brain structure, could different species with their own unique neural architectures actually experience the world in radically different ways? The implications are mind-blowing. And that's where we'll leave it for today. Thanks for joining us on this deep dive into the world of neuroscience.
Always a pleasure.